session is well architected for FileMaker. And my name is Mislav Kos. I work at Line Consulting. Been there for about 15 years. It's been a little while now. So that's me. This is Mike. Mike's not here right now, but I wanted to get his photo up here as a way of saying thanks because he had a hand to play in to putting the session together. So thanks, Mike. Okay, so first I want to do some expectation setting. Talk about kind of what is the session going to be about, right? So there's this concept of a well-architected framework out there, and you can think of it as a kind of process or checklist that you can use to judge if something is built to be safe, robust, or scalable. Lots of platforms have these kinds of things. And what I'm proposing is that we have one for FileMaker, call it well-architected for FileMaker. Now, as I was rehearsing this session, I got a range of feedback from folks. Some people said, "Oh, great! You got to give a talk that's going to list out all the different best practices. That's great. That's what I'm interested in." But some other people said, I know what the best practices are. Like, I don't need you to tell me what those are. But if you give me a tool that gives me a way to sort of track those and kind of go through those in a systematic way that creates actionable plans for me to follow, that's useful to me, right? And so my predicament is, which one of those are you, right? Are you somewhere between, right? Are you a person who's looking to get a list of best practices and would benefit from that? Or are you someone who feels like you already know what those are, but you could use a tool that'll talk you through those? Or maybe you're somewhere in between and you'd like to know what some of these best practices are, but you can then kind of tailor those to your own needs. And so my hope is that if you're either any one of those people, you're going to get something out of the session. So what I'm going to do is I'm going to describe what the framework is, what are the different building blocks. In the framework, again, this is the process that you use to evaluate your architecture. I'm going to show you a FileMaker-based tool that Mike Duncan developed that you can use to guide you through the process, and you will get access to that tool. And I just want to point out that the framework is just that. It's a framework, meaning that it's like a checklist tool where you get to decide what goes on the checklist. So I've created a list of checklist items that I find helpful, and I'm going to make those available to you. But I encourage you to sort of think through it on your own and to tailor that list so that it makes sense for your system that you're working on. In the last part of the talk, that's where I'm gonna go through some samples of best practices and then kind of go into detail for those. So I'm hoping that you will leave with a better understanding of how to systematically evaluate the architecture of your solutions using the framework. And then you'll learn some of the questions that I think you should be asking of your solutions, and then access to the tool that you can use to populate with your own evaluations. For the rest of the session, this is the agenda and I'll follow. I'll spend some time talking about architecture in general. What do we mean when we say architecture? I'm going to dive into the framework and then sort of talk about the different building blocks. We're going to take a look at the tool that I mentioned. We'll talk about how to go about performing a review, and then we'll dive into some examples of best practices. All right, so first, I imagine that many of you are probably would sort of identify first as primarily as a developer. And maybe even if that's not true, it can be helpful to think of architecture in contrast with the developer role, because that's probably very intuitively familiar. We know what that is exactly, right? So a developer the focus is going to be more granular, more focusing on a specific feature that they're building. And in contrast, an architect is going to be looking at more system-wide decisions. In terms of a time horizon, the developer is going to be focused more short-term on the specific sprint iteration or release cycle. And an architect is going to be thinking more long-term, kind of years down the road, right? And in terms of a mindset, developer is more pragmatic. I need to solve a certain specific problem, and an architect is more strategic-oriented and more design-oriented. But even though these two roles are listed as two distinct roles here, I tend to think of it more as the thing on the left than the thing on the right. So I think there's overlapping concerns there. And if you're someone who's an architect or someone who's a developer, you're still going to be thinking about those things that maybe nominally fall under the part of the other person's role. And so for me, if I kind of think of, okay, well, if I'm going to define architecture, what's the kind of the core of it? Maybe the definition would be kind of thinking about how different components within a system interact with each other. But there's other things that I think are within the scope of architecture that might not be immediately obvious. So list of some of those things could be code quality, backups, deployment effectiveness, software performance, security, so on. Now, many of these, you may notice, fall in the realm of non-functional requirements. Now, this term non-functional requirement, that might not be clear to everyone. So let's go over that a little bit. An example of a functional requirement would be when I click a reset password button, I receive an email with a reset link. Right? And then a non-functional requirement might be I receive that email within 30 seconds. So in this case, it's a performance-related non-functional requirement. And so these examples of sort of architectural concerns, a lot of them do fall within this non-functional scope. And we can think of these as the different ilities of the system, right? Maintainability, reliability, scalability, performance ability. You can have that last book. The rest of them fit in there nicely. All right, so let's circle back to this notion of a framework, an architecture framework. So what are we talking about? So it's going to be a collection of this design principles and best practices. And in sort of working your way through those, it helps you understand the decisions that you make while building systems. It provides a structured approach to doing a number of things. One is just to learn what the best practices are, right? We have a systematic sort of list that you can work your way through and see if you're following those. And that would be when you start to measure your architecture. And this is where the tool is going to come in. We'll talk about that a little bit later. And then as you measure your architecture, the outcome of that is an improvement plan that you can use to improve your solutions. Over the years and decades, as computer science has been sort of taking shape and evolving, there's been many variants of these architecture frameworks that have been created. One of them is AWS well architected, and it's aligned. We have a practice that does AWS consulting. And so we've become familiar with this framework. And the framework that I'm proposing, well architected for FileMaker, is heavily styled after the AWS framework. Now, at this point, I'm remembering that as I was becoming acquainted with the AWS framework, that even though every step of the way, I felt like I was understanding the different, things that were being introduced to me. Didn't feel like any particular thing was complicated, but overall, it wasn't quite sort of gelling, coming together, and it felt a little fuzzy and vague, right? And so I want to offer a kind of simplistic definition here. And actually, this is I see Wim standing in the back of this, something that I heard from him. He has a nap, which is kind of distilling something into just thing that you need to know, right? So I'm going to offer a kind of simplified definition of the framework. It's simply a questionnaire, and it has an action plan as the outcome. Right. So as we go through the rest of the session, just hold on to that sort of simplified explanation of what we're talking about. Simply a questionnaire. It gives you an action plan, which we'll call an improvement plan, as the output of the questionnaire. All right. So now we're going to dive into the framework itself, and we'll talk about different components that make up the framework. It can be helpful to think of them as falling into one of three groups: content, data, and tools. And so with the framework, we could use it to learn how to measure your architecture against best practices. Best practices would be part of the content. We're going to see how we can learn what questions to ask and how to organize what structure to use for those questions. So those are all things that we could think of as falling in the content domain. As we record our answers to the questions, we're going to use the tool to do that recording. And we can think of the answers as the data portion of the framework. And also the improvement plan that comes out of the tool, we could think of that as the data portion as well. We'll dive into the content piece a little bit more next. Three concepts or three terms that we'll talk about: design principles, best practices, and questions. We'll use some examples to sort of illustrate what each one of these is. So an example of a design principle could be design for failure and recovery. And design principles are there to inspire a set of best practices. So for the best practice examples, we could say you want to use regular backups and you want to revert to last known good backup. And we can see that the best practices are concrete steps. We're either doing them or we're not, right? So they're measurable, they're actionable, they're prescriptive. And in contrast, design principles are more high level and abstract, and they're intended to guide your overall approach. As we list out our best practices, we can then start to ask questions about them to assess our adherence to those best practices. So, for example, we could ask, how are you ensuring the system can recover quickly from unexpected failures or data loss? And then we would select which of the best practices we are following to do that. Now, as you start to compile a list of questions, at some point the list might get a little long, and it can become useful or helpful to organize it in certain ways. And so the word that we'll use for the category or group of questions is going to be pillars, right? So design principles and questions, we're going to organize them into pillars. And here are some examples of pillars we might use. But again, this is customizable, and you can choose how you want to organize it. But the ones that I'm proposing: operational excellence, security, reliability, performance efficiency, and maintainability. Now, the next term I'll introduce here is a lens. And a particular question, a lens is simply a particular collection of questions of best practices. You sort of figure out what that collection is going to be so that it can provide a focus on a specific, could be an industry. For instance, maybe you have a financial services lens that focuses on ask questions of solutions that have to do within that industry. Or maybe you have a certain technology domain like data analytics, or maybe a certain delivery model like software as a service. I suspect for most of us is going to be a specific application, the application that we're maintaining or taking care of. And the questions in the lens could span multiple pillars. So you could have some questions that come from a performance lens, other questions that come from a security performance pillar, and others that come from a security pillar. The idea is that there might be some pre-configured lenses out there that folks in the community build that you could use. And I've built one of those. I would call it a starter set. And I've sort of had in mind larger, more complex FileMaker solutions as I was putting that together. But remember that small solutions become complex and large over time. So it's good to start early. And I think really any solution can be useful to kind of do a review on any FileMaker database with that lens. So we'll have one lens that I put together, but the tool allows for you to build your own lenses. And so the community could build out additional ones here. And you can also just create your own custom lens, right? So you can take an existing one as a starting point and then tailor it to suit your specific needs. You can add or remove questions to it. So recall, I offered this kind of simple explanation of the framework. It's essentially a questionnaire, right? So the lens is the questionnaire, right? That's the collection of questions. The next term I'll introduce is the workload. And this is simply the thing that you are reviewing. In most cases, for us, it's probably going to be the application that we're taking care of. But it could be a process, an infrastructure, a team, or a combination of those things. All right, so we've talked a bit about some of the building blocks of the content portion of the framework. We talked about pillars, design principles, lenses, questions, and best practices. Next, we'll talk about the tool, which is where we use to record the data part of the framework, our answer selections, and the approval plans. All right, so the tool consists of two parts. The first is a kind of admin part where you build the lens that you want to use. Tool is going to come preloaded with one of them, and then the community could build out additional ones. And then the other part of the tool is where you use the tool to fill out the questionnaire, the lens. And as you fill it out, the tool then generates an improvement plan for you. Let's take a look at the first part, that admin part where we build the lens. This is it's a FileMaker database, right? So there's a list view of the existing lenses. You can click on one to edit it, or click one to create a new one. Then you define the lens to give it a name and define the pillars that you're going to use for it. If you click into a pillar, that's where you can add questions. And once you've filled out the lens, you can then export in a JSON file format. The JSON file format could be used to import the lens into the AWS framework tool, because they have a tool like this one. If for some reason that's useful to you, you can do that. And similarly, you can go the other direction. You can import the last JSON file into this tool. If you click into a pillar, that's where you can edit the different questions. You can see the existing questions or add new ones. And if you click into a question, this is where you can define what the question is and list out the different best practices that could be the answer choices for the question. Now, those answer choices, each one of those maps to a best practice, right? So when we say answer choices, we mean best practices. So for instance, if we ask this question that I used as the example before, how are you ensuring the system can recover quickly? We could list out 3 answer choices. Each of those is the best practice. And the idea is that we would then select which ones we're following. So in that sense, it's a multiple choice question. Right? We could say, okay, we're doing the first 2, we're not doing the third one. Now, each answer choice could have links to one or more helpful resources. So the idea is that you sort of read up on the best practice and learn the different things there are to know about it. For example, it could be links to knowledge-based articles or blog posts, or maybe a service offering or a product that could be helpful to implement the best practice. As you answer a question, you're going to get a risk assessment. It's either going to be low or no risk, or medium or high. So for instance, our example of best practices, if we were to say we're following all of these, maybe we design our risk rules to say, okay, well then there's no risk. If we're following all of them, then there's high, or if we're following none of them, then there's high risk, or something in between, we could say medium. Now, this is just an example of what the rules could be. They're customizable. And when you're defining a question at the bottom, that's where you sort of create the Boolean expression that tells you what the rules are going to be, how you determine, how you assess the risk level. Okay, so this was the part of the tool that we used to build a lens. Let's look at the other part, which is where we use the tool to perform a review. So we would create a workload record. Again, a workload, that's the thing that you're reviewing, your application or whatever that is for you. You give the workload a name and a description, and then you select the lens or lenses. You could select multiple lenses to use in the review. And once you and then you would fill out the questions. And then once you fill out the questions, there would be an option to create what's known as a milestone, which is simply a snapshot in time of your answer selections at that point in time. So the idea is you perform a review today, create a milestone that records your answers, and then maybe 2 months later you do another review, create another milestone, and you kind of have these comparison points that you can use to measure your progress. If we go into the middle part where we do the actual review and answer the questions, that's where we would see the list of questions, and then for the current question, we'd see our list of answer selections, and also the list of helpful resources that are defined for the best practices. And so this is where you could then read up on the best practices and sort of learn what what there is to know about each one. And then as you make your answer selections, there's a risk assessment for the question. So that's shown at the bottom. Now, again, this tool was developed by Mike Duncan, so thanks to him for doing that. And I'll show this download link again at the end. Let's talk about how to do a review next. There's 3 phases to this. You would prepare for the review, then you would actually do the review, and then you would act upon the review, so to improve your solution. For the prepare phase, this is where we define the scope of the workload. This is where we identify the sponsor. These are the folks who will be answering the questions, and we would also specify an owner for the improvement plan. We would hold a scoping meeting where we would decide which questions are relevant. There is a not relevant option for questions and best practices. So you could sort of say, okay, this question doesn't quite apply to me. And you'd identify who would be answering which questions so that those folks can then go and do some homework to read up on the best practices and to collect any information that they're going to need to evaluate their solution. When we're doing the actual review, that's where we're using the tool to run the review, record our answers. And once we're done with that, then the tool will generate an improvement plan for us. And that will simply be the list of best practices that we indicated are relevant, but that we said we're not yet following. And then you can further prioritize those to be either just the high risk items, or also you could also include the medium risk items. That's up to you. So you will get out of this a list of best practices that you could be following, and you can further prioritize that list based on level of effort. You could create Jira tickets for it, or add it to your backlog and work through it. Now, maybe the most important slide of the session here, some tips for the review phase. You want to make sure you adopt a blame-free approach. It may be helpful to realize that typically people don't make bad decisions; they neglect to make decisions, right? So, as a way of an example, team members don't typically decide not to back up data. They just forget to talk about it. Right. So having something that's going to systematically remind you of all the different things to think about can be helpful in that way. Most workloads have high risk items. That's just a fact, right? So finding them is not a bad thing. It's a good thing. You want to keep the review lightweight, think hours, not days. And you want to keep it a conversation, as opposed to kind of a feel of an audit that may have a kind of punitive or judgmental sort of tone to it. But it's an opportunity for reflection on the decisions that we're making about our system. In terms of timing, it's best to do a review early in the life cycle of a workload or solution because it's easier to make course corrections early on. And then you'll want to repeat it throughout the life cycle. So you want to have periodic reviews. And then after each review, you can create a milestone to track changes over time. And because you're going to be, or the idea is that you would periodically repeat this, it can be thought of as a mechanism for continuous improvement. Right. So we learn what the best practices are, we measure our solution, then we improve it, and then we repeat. Okay. So for the rest of the session here, I'm going to dive into some best practice examples. Remember I said that the tool is going to come preloaded with a starter lens. So there it is. I'm going to pick it out. So you can see it's, there's enough there that's just too much to cover in a session, right? So I'm going to pick out kind of two sections of best practices and dive into that. First one's going to be, have to do with backups. The question we could ask is, how are you ensuring the system can recover quickly from unexpected failures or data loss? And we can list some best practices for this. I'm sure that, you could all kind of add some things onto the board here. I'm going to start with understand what your options are to start with. And then use regular backups. Now, as I was rehearsing this session, I was getting some feedback. Well, what do you mean by regular backups, right? So what I mean is, regular backups as opposed to progressive backups. Some people call these full backups. It's the FileMaker server schedules that, the backup schedules. So that's what I'm talking about. So use regular backups, use frequently. And in the event of some issue or a crash, refer to last known to backup. We could add more to the list here, but let's start with these four. And let's work with a specific scenario. Let's say we have a large database file. I see this all the time, so I'm sure many of you can relate. You have a large database file, and as a result, the regular backup is slow to run. It takes a long time to complete. And because the duration is long, users report slow performance while the backup is running. And so while we are following the best practice of using a regular backup, we are not following the best practice of take frequent backups because the performance suffers when the backup is run. And in our example, we're only running backups every 6 hours, let's say. So now let's say that we're facing a server crash. And we're now faced with the possibility of incurring a large data loss up to 6 hours worth. That's very painful for the business. And so the decision is made to roll with the potentially corrupted database file instead of reverting to last known good backup. So we're not following that practice. If we were answering this during a review, we might fill it out this way. We think we understand our backup options. We're doing the regular backups, but we're not doing those other two things. And as a result, the question indicates that it's a high risk. And our improvement plan would simply be the list of best practices that we're not following. So we'd like to do better. We'd like to follow the best practices, but feels like a sort of intractable situation, right? So what do we do? Well, it can be helpful to take a look at what the root cause is in the situation, right? And for us, we could look at the fact that the database file is very large. So that begs the question, can we make the file smaller? All right, so let's work it with another example here, another scenario. Let's say you have one big-ass FileMaker file, 200 gigabytes. I've seen bigger, but yeah, this is pretty big. And it consists of a large set of, let's call it static data. This would be data that isn't updated frequently, right? So it's largely read-only data. And that in turn consists of some record data and then a lot of embedded container data. Not uncommon, right? And then the rest of the file consists of record data that is not static. It's updated frequently. And there's some tables that relate to sales activities and some tables that relate to operations activities. And then we also have a small file in the mix, which has some more operations tables. And over the years, we've accumulated a lot of data. It's been in operation for 15 years, so a long time. Okay, so we'd like to start following these best practices. Where do we start? Well, let's start with understanding what our options are in the first place. Now, you may think to yourself, well, I know how regular backups work, right? I know that already. Well, one of the use cases of the framework is to really, truly learn the best practices, to kind of read up on all the different material that exists about it. And so one of the things to understand about regular backups is that they use hard links. So what does that mean, and what's the impact of that to us? Suppose that we have two files, and you take a backup at 9 a.m., and then an hour later, we want to take another backup. In the meantime, file A has been modified. File B has not been modified. So the way backups work is that file B, which has not been touched, a FileMaker server is simply going to create a hard link to the previous copy. And on the file system, it's going to look like two separate files. But really on the disk, there's only one file. And the implication of this is that less disk space is used, which is nice. But even nicer is that the backup is going to be faster because there's no time used to back up file B. The only thing that it needed to do is create a hard link to the previous location on the file system. So the implication for us is, let's look for some data that doesn't change very often. So if you recall, this is our situation, and we can hone in on the container data. That's a kind of going to be a likely culprit of that we can improve. And so if we move that data out and use external remote storage, all of a sudden we've made our main file much smaller. It's now down to 20 gigabytes. So that's great, but what else can we do? So recall that we have 15 years of data in our system, and the older data doesn't change that much. It's more of a kind of archival sort of reference role in the business. So we can archive that data, right? We could create an archive file or even delete data if it's not needed. Now our file's gone down even more. Okay, so what else can we do? Well, we could split the file. Now that might be a term or a mechanism that's not familiar to everyone. The steps for doing this are you can look them up with the blog post that's linked out there. It's pretty simple to do, and what it happens is kind of what's going to be visually represented here, right? You take one file, and out of it you get two files, and first file has some components of the original file, and then the remaining components are in the other file. And in doing so, you could take that static data and isolate it into its own file. And now our main file is down to 6 gigabytes. All right, what else can we do? So now we're down to just not static data. Remember that we had that other operations file that's in the mix. So let's go back to our understand your backup options. Another thing to know and understand about regular backups is that they use parallel backups. So let's look at how that works. Suppose we have 6 files in the mix. 3 of them are sort of sales activity file tables or files, and the other 3 are operations. And when records are committed in one of the sales files, it's typically accompanied by record commits in one of the other sales files. But the operations files tend to be untouched when sales records are updated. And the same is true in the other direction, right? Now, FileMaker used to back up all files sequentially. But starting in 19.5, FileMaker server monitors record commits to learn how these commits are grouped into different files. And so it creates groups of files based on that information, and you can see what groups it creates by going to that file that gets created on the in the FileMaker server install path. And the way it works is that within a group, files are still backed up sequentially, but the groups themselves are backed up in parallel. And so the overall duration for the backup is less. So what else can we do here? Well, we can split the file again, take advantage of parallel backups. And so if we move out the operations tables into their own file, now instead of everything being sequential, we can take advantage of this sort of parallel backup mechanism, right? So it's going to be a faster backup. So the final result, after doing an extensive bit of file architecture here, I look like this. And as a result, the slowest backup now operates at 4 gigabytes instead of 200 gigabytes. Right? So you can really make some significant improvements in this way. So remember, we started with our question, which was essentially how do you back up data, and we listed these 4 best practices. We can add to that list now. So we can add store container data externally, make use of parallel backups, store static record data in a separate file. And if we were filling out this review at the start, it might look like this, right? We're doing 2 things. We're not doing the other 4. Our risk was high. We did all of this, implementation of best practices, and now it looks like this, right? So you kind of compare and track your progress in that way using milestones. Let's reinforce some of these concepts, right? What we did an initial review. We created that first milestone. Then the framework identified best practices that we could follow. That's the improvement plan. We learned about those best practices. We then implemented them, did another review and another milestone, and we're using those milestones to track our progress. Okay? Now remember, we hone in on this as the root cause, and it looks like that paid dividends for us. But what about the second part there? Slow, regular backups, right? We can look at that and ask the question, is there a different backup mechanism that we can use? So this is another way to do backups that my impression is that it's less there's less awareness of it within the community. Value snapshots, this is an operating system feature. And the idea is that you pause your database files so that they're brought into an internally consistent state. And then you ask the operating system to run a snapshot, and then you resume your databases. And the whole thing is a sub-second operation. It's a very fast thing that happens. And there's a blog post that we wrote about this that explains how to go about implementing this. By the way, this is the primary backup mechanism that is used with our hosting service at Salient Cloud. It helps with the design principle of don't skimp on backups. Okay, so we can add that to our list, and let's add a couple more things. Use progressive backups. I've heard some grumbling about, well, should this really be a best practice? Because it does suffer from occasional falls on its face occasionally. And yeah, that's true, but it doesn't, it still works a lot of the times. And when it's working, you're going to be glad to have it because it's probably going to be the most recent backup that you have. So that's one. And then storing backups off-site, performing periodic tests of our recovery processes. And we want to back up code in addition to data, right? So we would do that by creating clones. Let's take a quick additional look at this store backups offsite. Our Salient Cloud service has this offering called OptiFlex DR, disaster recovery. It's a kind of set and forget thing where you can take your server, including on-premise server, and it'll continually sort of back up the entire this value there. So that if that server crashes in a way that isn't easily recoverable, you could within minutes have a standby instance in the cloud. Okay, so that's a little deep dive into backups. And let's take a look at let's talk about monolithic architectures. All right, so here I'm going to ask the question: how do you refactor monoliths into loosely coupled components? But before I start, just think our best practices for this. Let's do a little detour and kind of talk about some architecture patterns first, because I think we need to explain some of these terms, right? What do we mean when we say monoliths? We say loosely coupled components, and why would you want to refactor them in the first place? So we're kind of take a little sidebar here. We'll come back and tie it back to the framework in a little bit. So a big part of architecture is looking at how the different pieces interact with each other. And one approach to design that kind of architecture is having a monolithic solution. And by the way, FileMaker solutions tend to be monolithic, so it pays for us to be aware of what that means. So let's review some concepts that are going to explain this a bit better. Let's say we have 2 FileMaker files. We got our OBAF file and a proposals file. And we can think of these 2 files as 2 components within the larger system, and they interact with each other, right? So we might have a layout in one file, and that layout has a field that has a direct reference to the other file. So this would be an external data source for us, right? This is common in FileMaker solutions. If you have a field like this, we call that a dependency, and we would say that OBAF has a dependency on proposals. If you have one dependency, for one field, you have one dependency. 10 fields, you have 10 dependencies. FileMaker file didn't have thousands of these things, so it looks more like this, right? When you have many dependencies like this, we call it tight coupling, and we say that OBAF and proposals are tightly coupled. And that's a signature characteristic of monolithic architectures. Components are tightly coupled. Okay, but is that a problem? So I don't want to be dogmatic here and say that monoliths are evil and we should not build things in that way. But we should understand what the pros and cons are, right? So with a monolith, it is simpler to develop initially in a monolithic approach, and it can be easier to deploy because you're dealing with a single unified code base. But there are some pretty significant cons to monolithic approaches. The solutions can become much harder to maintain as they grow in size and complexity. And an outage can bring down the whole thing. It can be difficult to scale, and changes in one area can have sort of unexpected consequences in other areas. So to break this down a little bit more, I'm going to look at a case study. This is one of our clients that's come to us, and they have 10 FileMaker files, 4 of which are sort of the primary ones that users log into. They have an aging code base, multiple decades old, but the application is critical to the business. So it's very important that it runs smoothly, that it's reliable. So they came to us with a number of concerns. One of those concerns was maintainability. They said, look, it's difficult to have a technical understanding of the entire system. It's really complex when you kind of pop the hood and look underneath. And when we introduce a feature, it's difficult to do adequate regression testing. We think we tested fine, everything passes our testing, but then when we introduce it, there are these sort of unexpected ripple effects of the system. We're also concerned about reliability because we experience occasional unplanned outages for a variety of different reasons. And we have a lot of users, and we plan to add more users, so we're concerned how well the application is going to keep up with that user volume. And in general, we're just concerned that there's these sort of latent and hidden risks. These, we could call them underwater boulders, because we know that, we realize this is a mature solution that has grown organically without a strong emphasis on architecture and code quality. Now, probably a lot of you can relate to at least some of these things, right? I know I can. I see it all the time, and it's tough to sort of unwind these kinds of situations. The way that the client put it to us, they're saying, look, we know we have to do something, but we don't know what or how. We're feeling stuck. Right? It feels sort of this intractable feeling. And interestingly, if we were to rebuild, we want it to do the same thing it does now. So the problem isn't the functionality. The functionality is exactly what they want, right? It's those other things that we talked about, right? So this is those concerns, and this may look familiar to you, right? If we think back to the monolith cons, right? They map very nicely to this list. So what they're dealing is that they're kind of dealing with the pains of sort of that monolithic architecture. Okay, so now we can understand that, but what do we do about it, right? Is there another way? So if monoliths have tight coupling, what does it look like if it's not that, right? So instead of thousands of direct references, we could have one well-defined interface, right? It consists of a set of API endpoints and some webhooks. And when we have few dependencies like this, we call that loose coupling. We would say that OBAF and proposals are loosely coupled. So some monolith alternatives, some alternative architectures, distributed architecture, this is where components are split across different systems or servers. It could still be monolithic. There could still be tight coupling, but you started to split them up into different pieces. Service-oriented takes that further, where each component becomes sort of insulated and independent, and different components talk to each other through well-defined interfaces like APIs. Then a microservice architecture is like service-oriented, but the different components are even smaller in scope. Their task is just to do one thing, and so it allows for very independent and highly decoupled services. And one more architecture pattern here. This one's more of a messaging pattern. Event-driven architectures. This is where communication between components is based on events, and this allows for very loose coupling and for asynchronous processing, so that one component isn't blocked by another that needs to do something. So here are those patterns, and note that they're not all like for like. They do exist at different levels of abstraction. For instance, event-driven architecture is utilized by both service-oriented and microservice architectures typically. Okay, so that's sort of or loose coupling, right? But it also has its pros and cons. And I think that over the long term, it's easier to develop those because you're making development changes to a single component that now has fewer dependencies to worry about. And you can focus on each component scaling it independently of other things. It can be easier to scale. You can get better resilience and fault tolerance because one component could go down, but it doesn't necessarily have to bring down the rest of the system. An example I use here is if you're buying an item from some service, and let's say the component, the service that delivers the consumer reviews of the product goes down, it doesn't have to stop you from making the purchase. You can still make the purchase. You're just not going to have access to the reviews, right? So that's what's known as graceful performance degradation. It's not fully functional, but it's still functional. Another pro of loose coupling is that it gives you greater flexibility about technology choices, because for each individual component, you can make decisions about what makes most sense for that purpose. But as with anything in life, there's trade-offs. And if you kind of have a proliferation of these different components, you now have to contend with an increased complexity with the management of those components. And if you deploy an upgraded one, you got to consider the impact of the upgrade in the other components. And there's more communication overhead. So a direct field reference is going to be faster than an API call, right? That's just how it's going to be. All right. So now we understand, some of these concepts, and let's say we bought it the premise that we want to explore, sort of starting to decouple or refactor a monolith. But how do we do it? How do we go about that? So the general answer is do it slowly, do it incrementally. There's this a pattern out there that came up ordained by Mark Fowler. It's called the triangular fig pattern, and the idea is that it's a kind of fig tree that grows on top of other trees. And as it grows, it's I guess a kind of parasite. It's a little dark metaphor here. It sort of starts to wrap itself around the host tree, and it might even eventually take the place of the host tree in the ecosystem, right? So the idea sort of happens slowly, piece by piece, right? All right, so that's the general answer. But how do we specifically do this for FileMaker? So if this is our starting point, what do we do? All right, so first we're going to identify for the different entities, we're going to identify which is going to be our system of record. So if we're looking at the proposal table, we're going to say the proposals file is going to be your system of record for that data. Then we need to identify our rights. And what I mean by that is these are the places that creates, updates, and deletes happen. So this is where in the OBAP file, data from the proposals table is being updated. So let's say we identify this layout of these two scripts as X. That's where the rights happen. Now we need to refactor dependencies for rights, and we do that by moving that functionality into the component that is a system of record for that data. I'm not saying this is easy work. This would be a way to do that. Then we would create a read replica of the proposal record data. So we're going to create a copy of the table and put that in the OBAP file. And in there, it's going to be read-only to those other dependencies. And now we need to identify those. This is the reads and refactor them so that instead of pointing to the original source of data, they point to the read replica. And it's only allowed to read data from there. But now we need an update mechanism for that read replica, right? And that would be probably webhooks, right? Like if these different events happen, so we have event-driven architecture here. If a proposal is created or updated or deleted, then the read replica is updated accordingly. And because it's read-only, we don't have to contend with record locks, right? So it's going to be a simple operation to implement. It could also be done on a schedule. We could have an API call that runs every so often. It just gets a proposal laid out. All right, so that was a little detour, kind of exploring some of these other architecture patterns and frameworks. Let's tie that back to our well-architected framework. So remember, we asked this question: how do we refactor monoliths to loosely coupled components? So the first best practice is do it incrementally. Right? We don't want to do this thing all at once. And the recipe that we could follow is, this is a recap of what we were just looking at, right? We would first identify the seams. These would be the kind of logical fault lines in our solution that we could use to split it up into different components. Then we pick a component to isolate. We identify the dependencies that cross the boundaries of the components. We designate clear ownership of data, so-called system of record. We then identify the different domain sets that are going to keep read replica updated. And then we refactor dependencies. This is where we replace the direct connections, which causes tight coupling, with domain events, which causes loose coupling. And then we can rinse and repeat. And it is not necessarily to completely refactor so that there is no monolithic attributes in our system. I think a hybrid approach is probably going to make the most sense. As always in life, there's balancing act, right? So you got to figure out what is the right balance for you. Okay, so modularize monoliths incrementally. But the first step, I'll go back to the previous slide here. The first step, identify seams. Let's make that a best practice in and of itself, right? So we'll call that choose how to segment your workload. So workload segmentation is the practice of splitting your application along sensible fault lines. And you can do this in a number of different ways, right? That's sort of maybe the most obvious one, and the one we did in our example is to do it by business domain. So we can say all of our proposals functionality, that's going to be its own component. But remember the backup example we were talking about? In there, we took some static data and we isolated that into its own file, right? So we did that for performance reasons. So you could have that be a driving force for how you split up the file. You can also do it for this is disaster recovery or business continuity reasons. For instance, maybe you have a time entry component and that you consider that to be critical data. And so you decide you want to back that up more frequently and more redundantly. So you want to carve that out into its own thing. And it could be for reusability reasons too. So for one of our clients, we had a pricing calculator that we built for them. It was initially used by the FileMaker database with which it resided. But over time, other pieces of the ecosystem needed access to it. And so we carved it out into its own microservice so that as it was being accessed, it didn't impact the rest of the solution. So choose how to segment your workload. And then let's add those different architectures as best practices. Also use service-oriented architectures, use microservices, event-driven. And then the last one here, use well-defined interfaces. Another way that this is sometimes referred to is design by contract. So this would be APIs, webhooks. Okay, so the question here, there's a kind of a presumption or an implication. How do you refactor monoliths? The implication is that you want to refactor monoliths. And I want to sort of be careful not to create that sort of as a categorical truth, right? I don't think that's always going to be the case. There's always trade-offs to consider, and we need to stay responsive to the business needs. The refactoring effort is not going to be small, probably. Well, if you do it incrementally, you can make it manageable, but it's going to be still a significant investment. And does the pain of the monolith, how does that compare to the pain of the refactoring effort, right? So we need to consider all of these things. And if you decide that this isn't relevant to you, remember there is a non-relevant option in the framework. You just mark that as not relevant, and then you can skip it. And there's actually an interesting case study, interestingly from Amazon, which is kind of a poster child for microservice architectures. A couple of months ago, or maybe a year ago, this sort of came out. Their Prime Video team decided to actually go back from a microservices architecture to a monolithic architecture because they were suffering from poor performance with the microservices approach. So no silver bullets, no categorical truths in this thing. You got to consider all the different factors there are to consider. However, remember those monolith cons, right? Harder to maintain. Changes in one area can affect the other entire system, and so on. And the concern that our client came to us, and we know we have to do something, but we don't know what or how, right? The feeling of stuckness. So refactoring monoliths can provide a path forward. So it is something that we need to understand and consider. Okay, I'll do a quick recap here, and then we'll have time for questions. So the framework is going to give you a structured approach to learn what the best practices are, to measure your architecture. That's where the tool comes in. To improve it using the improvement plan, and then to track progress as you make your changes and you best practices. And we do that using milestones. All right, so here's the link to download that tool if you're interested in it. And all the questions now. Yeah.
So it's interesting when you say about the monolith moving, and it has the complexity, understanding the full system. Doesn't also splitting a FileMaker solution into multiple files introduce the same complexity?
It's I suppose the complexity is still there, but it's broken up into pieces. And when you need to attend to one of those pieces, you could focus just on that piece. because the way that it interacts with the other components, those interactions are constrained to that well-defined interface instead of those thousands of references. So one of our clients that's dealing with this kind of a situation, as we were doing an analysis of their systems, we learned that one of their FileMaker databases is accessed via ODBC by some other non-FileMaker system. And there's like 8,000 of these ODBC queries that they have. And we can't use the DDR to do an analysis of, kind of, like, we change this field or if we do this, like, we'd have to go through each of those 8,000 queries to understand what the impact is going to be. Right? But if instead the interaction is through an API, through, it's like these 5 API endpoints, then we just need to worry about how those endpoints are going to be affected as we make changes in the system, right? So you're kind of isolating things to a smaller component, and that reduces the complexity as you make changes. Yeah.
Kind of like backups. I understand the hard links, but
Yeah.
take a simple scenario. We're backing up every hour. We're only keeping 2 copies.
Yeah.
So first one, it's full backup. Next hour, say there was no changes. It's just all hard links.
Right.
Next hour, what happened? Still no changes.
Still no changes. It just keeps doing the hard link. I think I'm supposed to be a question. So the question was about the hard links. And if we take first backup, it's a full backup. Second one, some of the files have no changes, so you do a hard link. And then the third backup happens, but we're only keeping 2 copies, right? So what's going to happen is the first backup is cleared, but in my case, it was file B that was unmodified, right? It has that hard link, which is kind of pointer to the file. Operating system sees that there are still pointers to it, so it's not going to delete it. And then that third backup comes in, and it's just going to create another hard link to that file.
So C basically just overwrites. B keeps A.
Yeah. Now, this is an important point, right? If you only keep 1 copy of your backup,
Right.
then I think that you're not going to benefit from this. So you want to have at least 2 copies. And should have pointed that out. Yeah.
On that same topic of backups, well, first let me say thank you for sharing your thought process. This is really illuminating.
Thank you.
Validating. My habit is to keep copies of the DDR, and it hadn't occurred to me to keep clones. Aside from the difference of recovering a piece of code from a DDR versus a clone, what am I missing by keeping DDRs as my code backup instead of clones?
Right. So the question is it okay to just kind of back up my DDRs as a way of backing up the code? If you're not backing up clones, you could reconstruct your code, your layouts, scripts, and so on from DDRs, but it's going to be a lot of manual work. But if you have your clone, you have that code already in a kind of functional state, right? So that's the reason to keep clones. All right. More questions? All right. Sorry. Oh, yeah.
Well, what sort of, a lot of FileMaker systems start off quite small. Sort of at what sort of scale do you start to see the benefits from splitting out because of all the overhead on a really small system?
Yeah.
Monolith does make sense. At what sort of scale do you generally see the benefits from splitting it out into a more domain-oriented approach?
Yeah. I think that's tough to answer, but I will say that I think it's not easy work to break it up, break apart these components. And if it was built in that way to begin with, save yourself a lot of grief. Now that's where you run into that other, mantra or kind of a truism of software development, premature optimization. So what do you do, right? And I think it's fundamentally difficult decisions. I suppose if you kind of have an idea of where you're headed with your solution, that plan for that, for the complexity, because it's going to come your way.
Yeah.
Right. Yeah. So I guess no easy answer there, but yeah. Yeah.
Just a comment on splitting things up. Is that you do have to be aware of your user management. If you're using built-in FileMaker accounts,
Yes.
they have to build the user management system.
You do. If you're using internal accounts, it can be tricky to split up the files. So, one of the other items on in my lens, right, is it's a whole section on security, and one of those has to deal with establishing a strong identity foundation. And what that means, or one of the big ways you can accomplish that is to use external authentication. FileMaker can manage your accounts for you, but as I heard someone say, I think it was you, John, just because you can doesn't mean you should, right? And it's this is a constant fight I have to have with my clients to convince them that we don't want to have internal authentication. There's all sorts of reasons why it sort of constrains you, boxes you in, but it's not obvious initially because it's sort of simple to do, right? But then when you get in the situation where, okay, now we need to do some of these things like splitting files, if we had sort of followed the best practices initially, now we don't have to worry about that, right? But if you didn't, now you kind of, okay, now we got a whole bunch of stuff we got to change first. Yeah.
Yeah, when you're breaking out your dependent system from your system of record, and you're trying to keep the data synchronized so that if there's a change in the system of record, it updates the child data. Are you typically using things like the FileMaker API to do that, or what sort of mechanisms?
Yeah. So how do you? What is the mechanism for those updates for the re-replica, right? Yeah. We're typically using the data API, and we have it kind of worked out at Solion. We have sort of certain mechanism of doing it. And I was at Clay Mackel's talk yesterday. He was pointing out that we should start switching to OData. That's kind of going away.
More of my sections.
Exactly, yeah. So John's session was an OData. So, but data API, OData, right? That's the mechanism. Yeah.
So where do you, in the process of the, hey, we've done all the questions, here's what an action plan might be, where do you feed in? Because the two variable elements are, for the customer, they want to know what's the implementation load, and also what's the potential cost. Low load, but a higher cost. Some things may take more, but they've got a lower. So I'm just thinking about offsite backups. Wasabi, you can do that, but you have to keep them for 90 days. And then suddenly you got 20 gigs times 90 days. It's it's understanding where in that equation you feed that data into the thing that you present back to the client.
Yeah. I mean, what you said is an estimation technique that we rely on pretty heavily at Solion, right? You look at kind of the impact, the business value, and the effort, the level of effort, right? And then the low hanging fruit is versus low effort and high value, right? So that's a good way to prioritize. We'll start off by kind of listing out, okay, here's the possible things we might want to do, and then we'll go through a prioritization exercise that does exactly that, and we'll kind of see what bubbles up to the top. Right? I think some of that file architecture stuff, I think it's fairly low effort. So, I mean, there's effort involved, but it's pretty straightforward what to do. I think the refactoring all those thousands of dependencies, that's a lot of work. So I think that's higher effort. But again, in that case study that I mentioned, this is a company that has they got 24/7 operations around the clock, and they got a lot of revenue riding on this application. So my assessment is that they have to start doing something.
Right.
And have the money to pay.
And they got to commit, because it's going to be a long-term effort, and it is going to cost money. So I think there has to be buy-in to understand that, okay, this is a needed investment.
I was just curious, maybe from the tool or how you got a sidebar of the tool. Some of those things, like that maybe it's high risk, but the solutions are high cost, or maybe I guess all of those things are sort of like the spectrum of like dollars.
It is, yeah. So risk analysis is a whole other topic, and I've got lots to say about it. We pay close attention to that at Solion. My simple definition of a risk would be, what is how bad would it be, like the magnitude of the bad impact, and then the likelihood that it would happen. Right? The product those two things gives you kind of the severity of the risk, but it doesn't say anything about implementation and effort. Right. So I think if you do a risk analysis, you then have to do what John was describing, which is feed in, factories, the implementation costs. Right. Yeah. So you got to kind of see, how bad is it going to be, but also how much is it going to cost. Right? Yeah.
For the questions and the actionable items, it seemed like for the example was you could do all of them in a situation where best practice is to do something, but you have options that are mutually exclusive. Does the tool handle that sort of in like the same question? You need to break that out into separate.
Yeah. So the question is, if the best practices are kind of self-conflicting, you're not going to be able to follow all of them, because if you're following one, it means you're not following not going to follow the other, like the volume snapshot, right? Yeah, so this is where the structure of the framework, you kind of run into it being a constraint. And personally, that's a common thing that I run into. You kind of set up a certain structure and it works for you. It's sort of a good thing, but then it kind of creates certain constraints that you didn't anticipate. So in this case, I think I would just mark the one that that is not going to be relevant to me as not relevant because I'm deciding, I'm doing these other things, which means I can't do this one. So that was not relevant. And there's a little field where you could say, why is it not relevant? You would subtract that. All right. Thanks, guys.